So a typical academic house floor plan looks like this: 5 large classrooms and a resource room with some teacher rooms. And it's a 3-story building. All of the buildings we've done at Manassas Park have been 3-story buildings, even though they had a lot of land. And we think it's made for more energy efficient buildings, more compact footprints, but also it's important to get the kids moving. You got to get up and move every 15 minutes, especially if you're a little kid, if you want to keep your focus. And then this is kind of a closer look at one of the particular houses. This is the understory of the spring house, so that's the middle level of one of the academic houses. You can see teachers in a conference space here and kids here, and then some one-on-one instruction taking place into that hallway. The hallway is also lined with wood planks. These are all trees that can be found growing in the forest. The first thing I did starting the project is I had a meeting with the forester from the Department of Forestry. We walked the forest and identified as many plant species as we could, so I could begin to have a language, a database, if you will, design students. So this is the bottom floor. We have a polished concrete floor, which I'd like to hear y'all's opinion, but I'm not convinced polished concrete is going to be a problem. And so here they're very wide, 1x14, 1x12, they're spaced out, they're trunks. This is the understory. They get a little thinner, a little closer together, and this is the canopy where they become limbs. They're very close together. And then the mirrors in between them also allow the forest to get reflected down deep into the school and then vice versa. This addresses one of the issues that was brought up about restricted land. This is one of our stormwater treatment areas, and it's an outdoor classroom, but it's also biofiltration. And I've got some diagrams that show it. So water can come fill in. This is what would happen at a 10-year storm event, and that level stage was designed to mark that. And then a 100-year storm event is up at this level. I was hoping to get some stencils in the concrete to do that, but so a lot of the stormwater can be taken advantage of, but otherwise that's a fenced-off muddy retention pond, totally useless. It has no value. Where here it's got this great use. The band comes out here and practices, and it's a wonderful asset to the school.
So, I guess to quickly go over the systems that we have here. Again, this building was sort of the culmination of 5 projects. And the first project that we started had a water source heat pump system. It was the best life cycle cost that we identified at the time. And 3 of the schools, or 3 of the projects from that point had water source technology in them. A couple of them were 4-pipe. But they really liked the water source type systems. They deviated a little bit because of some existing systems that were there. So the geothermal part of this project, which it's all geothermal, was just sort of the next step for them. It allowed them to maintain the same sort of maintenance practices and not add to their knowledge, tax them